Hello, I'm Rob Reiner, Tachyum's Director of Product Marketing. I'm here to showcase our latest Prodigy milestone, where we demonstrate our early support for the Xen Hypervisor running on the Prodigy QEMU software emulation system. A hypervisor is a software package which creates and runs virtual machines, allowing multiple virtual machines to run on a single physical host system, sharing its processing, memory, storage, and I/O resources. Xen is a Type 1 or bare metal hypervisor installed directly on the host system's hardware. One of the features of Xen is its scalability. It can be used in various environments, from embedded applications to personal computing to large cloud and enterprise data centers. Xen supports 4 types of virtualization, providing the flexibility to address a wide range of use cases and workloads. Number 1, paravirtualization. In this case, the VM is aware that it's running under a hypervisor and performs hypercalls to interact with Xen. This is an equivalent of syscalls for user space applications. The second type is full hardware virtualization. The third type is full virtualization with a set of paravirtualization drivers. And lastly, paravirtualization with hardware virtualization support. Besides the virtualization types, Xen is also able to run in 3 different modes. The first mode is standard DOM0 mode. Secondly, Hyperlaunch mode. And thirdly, DOM-OLIS mode. In standard DOM0 mode, which is the original Xen design, there is one VM with special privileges running. It is called DOM0 and has the ability to control the other VMs and support paravirtualized back-end devices that are used by front-end drives in DOM-U, short for user domains or VMs. The standard use case flow is to run XL and launch a new VM from the command line. Hyperlaunch is a relatively new idea to the Xen world, first released in 2022, and allows VMs to be launched at boot time. The VM descriptions are defined by a device tree. DOM-OLIS uses a Hyperlaunch-like configuration, but with static partitioning, and as the name suggests, without using DOM0. The static partitioning means that there are no virtual devices, and the hardware resources are statically assigned to a specific VM as pass-through. It behaves similar to the Siemens Jailhouse hypervisor. What we are going to show in the video is a hyperlaunch of 2 VMs, the DOM0 and DOM-U1, described by its static device tree, passed to Xen at boot time. We will be showing Xen running on QEMU, a software emulation of our Prodigy platform. For one of the simplest devices, a UART, we are using 2 different types. The 16550-like UART to test MMIO, and a tile UART for virtualization of special registers. The main console is able to switch between the default DOM0 console, DOM1 console, and Xen console by pressing Ctrl-A 3 times. This is the device tree which describes the 2 VMs we want to launch. You can see the definitions for DOM0 and DOM-U1 kernels with the init read. With that, let's start Xen, which will use the configuration to create our VMs. We can now see the memory layout, which shows us where Xen, VM0, VM1, and init read S are placed in memory. Xen is now preparing our VMs. Right now it is unpacking an init read for DOM-U1. We have sped this part up to keep the video short. We can see the special HVC0 console, which is available only for DOM0. Our DOM0 VM has finished booting and we can now log into it. The HVC0 is using a hypercall to make Xen print the message, and in opposite direction, Xen uses upcalls to notify DOM0 about incoming characters. We can now, for example, list the /dev/Xen directory, which contains special files. The directory is available only for the DOM0 VM. The files are used by Xen tools to communicate with DOM0 kernel, which then performs specific hypercalls. For instance, setting a 30-second timeout for the Xen watchdog timer. So if the domain doesn't respond in 30 seconds, it will be killed by Xen. By pressing Ctrl-A 3 times, we switch the main console to DOM U1. We can see it is still booting. We can now switch the main console back to DOM0. Let's assign a message string into the message variable to show there are two different VMs. We switch the main console to DOM U1. The DOM U1 VM has also finished booting by now, so we can now log in. Let's assign a different message to the message variable. Now let's switch back to the DOM0 VM and print the message variable. As you can see, it prints the message previously assigned in DOM0, hello from DOM0. Now we switch to the DOM U1 VM and print the message variable. It also prints the value assigned in the VM before, hello from DOM U1. Let's switch back to the DOM0 VM one more time and show that the Xen watchdog service is running by executing system control status Xen watchdog. Now let's try switching to the Xen console. The Xen console allows us to inspect information about running VMs. We can list the available commands by pressing the H key. Let's display a dump of memory information by pressing the M key, and the domain information by pressing the Q key. We can see that there is a 2 MB shattered page. The DOM0 VM performed a syscall to create a shared page between the VM and Xen. Xen had to split 2 MB leaf of the second stage page tree into 4K leaves just to use specific mapping for a single page. Thank you for watching our Xen demonstration. This is an early version of our Xen port with multiple features still in development. Please stay tuned for more development updates and additional Prodigy milestones. Thank you.